In this video, I will be discussing the reason questions of D block elements. This is the second video on the reason questions of D block elements. So please watch the previous one also. Okay. So the first question says, highest oxidation states are found in the compounds of fluorides and oxides. That is with reference to D block elements, the question says. In D block elements, the highest oxidation states are shown only with respect to fluorine and oxygen. The reason for that you will write as fluorine and oxygen, they are having high electronegativity. They are having high electronegativity. Okay. There is no other point to be included in this. Okay, so only this is enough because fluorine and oxygen are highly electronegative elements. They D block elements, they show higher oxidation state only with fluorine and oxygen. Okay. Next one. The next question says transition metal and their compounds act as good catalyst. That you have seen so many examples, platinum, nickel, then you have vanadium pentoxide. They are mainly used as catalysts. So why? What is the reason for only D block element or transition elements being used as the catalyst? So the answer for that you are going to write down 2 points. Number one, you will write down because they have high tendency, transition elements have high tendency to form reaction intermediates. They form reaction intermediates, and those intermediates are unstable, and finally they will be forming the catalyst back, forming the product. Okay, so actually if suppose two reactants are there, so one of the reactant will react with these transition element, form the intermediate, and intermediate will again react with the next reactant to form the product. So this will help the reaction to lower the activation energy. They have the high tendency to form the reaction intermediates which lowers activation energy, therefore increases the rate of reaction increases. Therefore rate of reaction increases. First point you can write down this one. The second point what you can write is the transition metals provide large surface area. They provide large surface area on which the reactant molecules get adsorbed. In surface chemistry we study, they get adsorbed on the surface. So suppose this is the catalyst surface, it is providing a surface area, the reactant molecules get adsorbed onto it. When they get adsorbed means they are all coming together, their concentration increases, so rate of reaction also will increase. They will form the product will leave the surface, that is desorption will occur, and the same catalyst can be used again. So 2 points have to be mentioned why transition elements act as good catalysts. The next one is transition elements, metal ions have high tendency to form complexes. Now for this what you are going to write is the first point is the small size of the transition element atoms or ions. They have small size, so when they are having small size, they can get coordinated with the ligands, the surrounding ions easily. The second point you can write is high nuclear charge. Because of high nuclear charge, they are having high positive charge. So onto the positive charge, the ligands or the surrounding ions, they can give the electrons readily. The third point what you can write is the presence of d orbital. Presence of vacant d orbital, you can write presence of the vacant d orbital, which can accept the electron pairs from the other groups or the ligands. Right? So 3 points have to be written why they have the tendency to form the complexes. The next question. The question says that these transition metals have the tendency to form interstitial compounds. Okay. Now for this, what you will write is, the first point you can mention is that the transition metals, transition elements can accommodate small non-metallic atoms. Non-metallic atom. Which non-metallic atoms they can accommodate? Hydrogen, boron, carbon, nitrogen. Okay, why they can accommodate? They can accommodate these small non-metallic elements because they have spaces, because of the presence of the spaces between metal atoms. Spaces between metal atoms. There are gaps between them. This is the first point you can write down. The second point, you can further specify why there are spaces. The spaces are because of the defects in the structure. In solid state, we study there are certain defects in their structure. Because of the defects in the structure, there are spaces in between. And existence of variable oxidation state. Existence of variable oxidation state. So these reasons you are going to mention why they can form interstitial compounds. Right? Moving on to the next question. Mn2 plus compounds are more stable than Fe2 plus towards oxidation state. Now for this, you will be writing Mn2 plus getting oxidized to Mn3 plus, or Fe2 plus getting oxidized to Fe3 plus. You need to mention the configurations of both, right? So Mn2 plus, the configuration, if you write down Mn first, Mn configuration is argon, and then you have 4s2 3d5, right? So Mn2 plus would be just argon. I'm not writing, this will go away, so it's having 3d5, and this is having 3d4. What about this? If you write Fe configuration, Fe is argon, 4s2 and 3d6, right? So this is 3d6 and this one is 3d5. Now with the help of the configuration, you can make out very easily that for Mn this is more stable, for Fe the second one is more stable. Therefore Mn will be resistant to oxidation, whereas Fe can prefer undergoing oxidation so as to form the stable oxidation state. Clear? Now moving on to the next question, which says the ionization energy of 5D elements is greater than 3D. Now what reason you are going to specify? In the previous video I have discussed about the ionization energy variation. So 3D, 4D and 5D. We know that 4D and 5D series elements have nearly the same size, right? So what happens is, just before this member, here you have lanthanum, then you have hafnium. This is 57, this is 72. Between them there are lanthanides. So due to lanthanide contraction, it is found that the 5D series elements are having comparatively smaller size. So they are having smaller size, means their ionization energy will be more. So what reason you will write down? Why do they have greater ionization energy? Answer is lanthanide contraction. Lanthanoid contraction. This is one of the application, the consequence of the lanthanide contraction, we can say. Which divalent metal ion has the maximum paramagnetic character among the first series? So first thing is, we should be knowing the element which is having the maximum number of unpaired electrons. So it is Mn. Mn in divalent state also has 3d5. So it's having maximum number of unpaired electron. Paramagnetic character means more the number of the unpaired electron, more will be the paramagnetic behavior. You can also be asked to calculate the magnetic moment, which is calculated by the formula root n into n plus 2. So you have to just count the number of the unpaired electron. 5 unpaired electrons are there, so 5 into 5 plus 2. This you have to see. So in this particular question, you don't have to calculate mu, but mu is one of the property to exhibit the paramagnetic behavior. More the mu value means more unpaired electron it is having. So more paramagnetic behavior it will show. Out of cobalt and zinc salts which gets attracted in the magnetic field. Salts they are asking. Salts means they are talking about ions. So for cobalt 2 plus, for zinc 2 plus. So this is 3D10. 4s2 has gone. And what was cobalt? Cobalt was iron, then you have cobalt. This is 3d6, 3d7. So this is 3d7, 4s2. That means CO2 plus would be 3d7. So which is having unpaired electron? This one. This will not be attracted toward the magnetic field. This will be attracted. This is having paired electron, means zinc would be diamagnetic. It would be diamagnetic. It will be repelled when placed in the magnetic field. This will be attracted when placed in the magnetic field. Got it? Next, silver metal atom has completely filled d orbital in the ground state. Then how can you say it's a transition element? So for that you will write down silver can also form 2 plus. So in 2 plus state it is having unpaired electron. That means in the ground state it is having 4d10 configuration. In the ground state silver has 4d10, but in this state it will be having 4d9 configuration. So it is having unpaired electron. So because it is having unpaired, we will say it is a transition element. So that is why you say group 11 elements. Group 11 elements means copper, silver, gold. They are called as a typical transition elements, because only in the ionic state they can exhibit their property. In ionic state they can be considered as transition. So in actually one of the state they should be having unpaired electron. So at least in ionic state they have unpaired. Therefore group 11 is called as a transition element and group 12 is not, because in group 12 they are having paired in both atomic as well as ionic state. Yeah, moving on to the next question. Name the oxometal anion in the first transition series in which the metal exhibits the oxidation state equal to its group number. So in this you will be writing two examples, MnO4 minus and CrO4 2 minus, wherein Mn is having plus 7 which is equal to the group number, and this is having plus 6. Clear? Next, cobalt 2 is stable in the aqueous solution, but in the presence of the complexing agent it is easily oxidized. So what you will write is, for this case, in the presence of the complexing agent, cobalt from plus 2 gets oxidized to plus 3, which is more stable. In plus 3 state it is more stable. So in the presence of the complexing agent it gets oxidized to this one, which is more stable state for cobalt. Clear? Next, D1 configuration is very unstable in ions, because after the loss of this one electron, after it loses that D1, normally it is what? Some noble gas configuration is there plus D1. So it has to be unstable, because after losing one electron, D1 electron, it results in the formation of the stable configuration. The stable configuration, therefore it always prefers to do that. It's very unstable and prefers getting stable. What is meant by disproportionation reaction? Give two examples in the aqueous solution. So for that you will write disproportionation reactions are those in which the same element is undergoes oxidation as well as reduction. Same element is undergoing both in the same equation, right? So for this you will be writing two equations, CrO4 2 minus plus H plus. It results in the formation of, this one will be 3 minus. CrO4 3 minus plus H plus. It results in the formation of CrO4 2 minus plus Cr 3 plus water. Okay, you can balance the equation. This would be 3, this would be 8, this is 2 and 4. And 4. So this is the complete equation you're going to write. Apart from that, you can also write one more equation, MnO4. MnO4 2 minus plus 4H plus. So when you're balancing, this will be 3. 2 MnO4 minus plus MnO2 plus 2H2O. You can just cross check on your own the oxidation state, what are the changes. Okay, here it is 6 Mn, it is becoming 7 and it is becoming 4, means it is increasing as well as decreasing. The same element is undergoing increase and decrease, right? Copper cannot replace hydrogen from acids. You can write 2 points. Number 1, its E0 value is positive. That's how you write. For this value, you write it as plus. Therefore, copper is less reactive. It's less reactive than hydrogen. Therefore, it is the answer. First one. Second, the first ionization enthalpy of chromium is lower than that of zinc. Yeah, I hope the numbering is wrong. This is 15, this one is 16 and this is 17 question. For this, I did not leave space. So for 15th, I am writing the answer down. Okay, for 15th one, I am writing here. Chromium first ionization enthalpy is lower than that of zinc. So chromium and zinc, you will be writing the configuration. Chromium configuration is argon and 4s1 3d5. And this is 4s2 and 3d10. Right? Why this is lower? Because after losing this one electron, it will be becoming more stable oxidation state, half-filled d orbital. Half-filled d orbital, it will be acquiring half-filled d orbital, which is more stable in comparison to this one. Whereas here, after losing this one electron, it is still not stable. So definitely it will be slightly more. It is S2, it is completely filled. S2 is completely filled. It will not like to lose electron readily. Wherein this will easily lose. So 2 points you can write. Number 1, nuclear charge is, configuration wise, this is more stable, this is less stable. So it can lose. Second, after losing it is becoming more stable. After losing also it is not becoming that stable. Clear? Next, halides of transition elements become more covalent with increasing oxidation state of metal. So what you will write in this is that on increasing the oxidation state, you can write that as oxidation state increases, the size, what happens to the size? Size decreases. So what, as per Fejan's rule, what you say? Smaller the size, more is the covalent behavior. More is the covalent behavior. More is the covalent behavior. That is to be written in this. So, transition elements are becoming more covalent with increasing oxidation state. More the oxidation state, smaller will be the size, and smaller the size means more covalent behavior. Next, it says the reactivity of the transition elements decreases almost regularly from scandium to copper. So what you will write in this is because of regular increase in ionization energy. Lesser the ionization energy, more the reactivity. So as ionization energy is increasing across, therefore the reactivity will be decreasing. Okay, so please practice these questions. You can write down all the recent questions together, part 1 and part 2. So with this we have completed all D block recent questions. In the next videos, I will be writing, explaining the D block elements, the remaining part, that is the complex compounds of potassium permanganate, chromate, and of course F block elements also. Okay, thank you.